by the Nigerian Institution of Highways and Transportation Engineers in collaboration with International Road Federation Global. May I please request that if you're here for this training and you're outside, please come in as we begin immediately. May I please request that we'll be upstanding as we recite together the third stanza of the national anthem as our opening prayer. Together we pray. Together we pray, O God of all creation, grant these our one request. Help us to build a nation where no man is oppressed, and so with peace and plenty, Nigeria may be blessed. Amen. Let's take the national anthem. Can we get national anthem? Good. Thank you all. Let's have our seats. So a quick one. I'll run you quickly through what we had yesterday, and then we'll have a pep talk for a few minutes, let's say 3, and then I'll take the citation of our lead speaker for today, and then we continue quickly to our lectures. But before then, I'd like to recognize here the Deputy National Chairman of the Nigerian Institution of Highways and Transportation Engineers, our very own engineer, Dr. Bola Mudashiru, Fellow of the Nigerian Society of Engineers and Fellow of this great institution. Let's put our hands together for him. We have also here present the immediate past National Chairman of this great institution, Engineer Sehidu Hassan, Fellow of the Nigerian Society of Engineers and Fellow of the Nigerian Institution of Highways and Transportation Engineers. Let's put our hands together for him. And we have the pioneer chairman who ensured that this institution is always up and running, and you can see that in his activities, especially even at the training. He doubles equally as the chairman of the planning committee for this training. Let's put our hands together for Engineer Isa Usman Imoabinu, FNSE NIHTE. Let's put our hands together for him. We have also here a past national chairman of this institution. Let's make welcome Engineer George Unsonwu, FNSE NIHTE. And we have one man who is always concerned about infrastructure. He was a commissioner of works, Benue State, a past vice president of Nigerian Society of Engineers, past registrar of Koren, past executive secretary of NSC. So you know he's an institution's person. Let's make welcome also Engineer Dr. Felix Atumi, Fellow of the Nigerian Society of Engineers, Fellow of the Academy of Engineering, member of the National Institute. And we have also here, I know yesterday you have enjoyed his teachings, so if I call his name, the way you applaud him would equally show how you enjoyed his lectures and trainings yesterday. Let's put our hands together for Dr. Amin Aknok. As you know, he's a professor of construction engineering and management at East Carolina University, North Carolina, USA. And today, we now have, he came in at the tail end of the lectures yesterday, but today you will enjoy his own mix of the training. He has come with so much from Ghana. Let's put our hands together for Engineer Dr. Patrick Amon Beke. Dr. Patrick, I'll call you later. Yes, this one is for us to know you very well. You can see he's eager. The thing is too much. He came, he wants to pour it. Clap for him again. When we read the citation, you will now know why he has stood up to come and deliver quickly to you. Thank you. And we have also here present at this event, Engineer Dr. Ayo TB, a retired director from FEMA, a member of the Board of Trustees of NIHTE. Let's put our hands together for him. And I'll quickly run through this list again. If you are here, you just wave your hands. We need to celebrate you every day. And because we are happy that you are part of this training. We already have NIBRI, Nigerian Road and Building Research Institute. If you are here, wave your hands wherever you are. Let's clap for them. Yes, clap for them. You will not know if they are in the front or they are at the back. Then from the Federal Road Maintenance Agency, FEMA, clap for them. You are welcome. Federal Ministry of Works, you are very, very welcome. Ministry of Regional Development, Rural Access and Agriculture Marketing Project, that's the RAMP project. You are very, very much welcome. Then my favorite people, the money people, Keystone Bank. Yes, Keystone Bank. Pardon? Yes. And then our international delegates, Ghanaians here present. Please stand up. Let's celebrate you. Yes, thank you. And all those who will be joining us online, we appreciate you. We celebrate you. Once again, my name is Engineer Emmanuel Oshala Ejika, MNSC PMP. Pardon? Keystone. No, I've done that. I don't joke with them. Keystone, they say I should recognize you again. Keystone Bank once more. Put your hands together for them. Yes, thank you. I'll be leading you, directing you through this program. The Make Way Media, we appreciate you. Protocols, gentlemen of the press, ladies and gentlemen. So our safety briefing remains the same. I just want to reiterate it and refresh your minds once more. We have 2 exit doors, the one you came in through and one at the back. The one at the back leads you to where you have your coffee and lunch breaks. And we have the conveniences just behind me on the stage. To my right is the gents, and to my left, the ladies. You can access them through this door, or you go behind. There is a small door that takes you inside, and the positions remain the same. We do not have safety drills here today, so if you hear any sound, any alarm, it's the real one. Ensure you get yourself to the muster point that is just at the car park before the ramp that takes you out of the building. Please ensure you have gone out with your neighbors. And please, if you need water, keep yourself hydrated. Relax. We know the atmosphere is conducive. And most especially, please keep your belongings very, very safe. We are in an open environment. We need to manage ourselves. Thank you very much. If you need anything, you can talk to me or to the ushers. You can see them and organizers in blue t-shirts and cap, looking very, very well to ensure we are well registered and have a good event. Please put your hands together for yourselves. So, without taking much of your time, first we are going to have the pep talk in 3 minutes or less, and then we'll give the citation of our speaker and then continue to the training. May I now invite Engineer Dr. Ayo TB, a retired director from FEMA, to give us the pep talk. Let's put our hands together for him.
Sugar. There's something wrong. Good morning, distinguished ladies and gentlemen. We just want to add flesh a little to the program. It's not just all engineering, even though I'm an engineer. Shege, put it now. I would have brought my own to read. They do like this with the slides. Okay. We have I call it the church series, even though you call it pep talks. The first one should have been taken yesterday, the power of information. Then the second one. But let's take the first one. The power of information. Okay. In my own opinion, nothing empowers like information. To be informed is to be transformed, and to be informed is to be transformed, and to be uninformed is to be deformed. Information is both the gateway for man's advancement and the cure for all his frustration. There is no substitute for information in your quest for change of position. I consider information as any bit of news that influences your thought and action. It is the force that rules the world. It is the force that rules the world. You didn't give me again now. Life is determined by the quality of information at your disposal. You should have given me now. Life is determined by the quality of information at your disposal and the level of insight with which you are operating. How far you can see determines how far you can go. You cannot go beyond the information at your disposal. The brighter you are, the faster you go. The more informed you are, the greater the result you command. I see information as the currency of destiny. It determines your purchasing power in the market of life. Everything you are or do today is as a result of information of yesterday. But mind you, the information of yesterday may as well be obsolete today. The news you acquired determines the moves you generate, and the moves you generate determines the waves you cause, which determines the news you make. It's a continuous cycle. Unfortunately, learning stops for many as soon as they graduate from school. But as Abraham Lincoln said, I don't think much of any man who is not wiser today than he was yesterday. We live in a changing world, so you have to keep pace and current with knowledge. If the information at your disposal is obsolete, then it cannot produce any current result. I want to believe that tradition is the worst enemy of civilization because it has no regards for current knowledge. Anyone who stops learning is old, either at 20 or 80. Anyone who keeps learning stays young. The greatest thing in life is to keep your mind young, to keep one's mind open to new insight and information that will help in generating solutions to bugging issues. Even the so-called gift of wisdom can become stale if you do not learn from others, because iron cannot sharpen itself. It has to be sharpened by another iron. If you are not rubbing your mind with others, it will soon become dull. Everyone aiming for an outstanding future must be committed to rubbing his little mind with the greater minds, thereby becoming sharper by the day. No matter your field of endeavor in life, if you are not studious by way of information, you are heading for shame without knowing. A time will come when the things you are saying will no longer be relevant to the needs of people around you. To be a man or woman of impact, you must be committed to an insatiable hunger for ever increasing insight in your field. A wise man said, you will be the same that you are this year, even in 5 years' time, except for two things: the books you read and the people with whom you work. You are here today to be informed in various areas in your profession. Dr. Abin, the lead instructor, will keep you informed on the history of pavement design theories and their impact on roadway condition. Like I said, it has already happened yesterday. You will also be introduced to how AI is used in road asset management. Mechanistic empirical pavement design guide will be your tour guide away from totally empirical Marshall mix design. You realize that you don't only need reactive maintenance, but pavement preservation for sustainability of our road assets. At the end of this program, you will access to professional materials. You have access to professional materials that can enhance your skills and help in your pursuit of excellence. And I am also convinced at the end of this professional impartation that you will either be running with a vision, going on a mission, or burning with a passion, belong to any of these. Happy participation.
A round of applause for Dr. Ayo TB. Thank you. That was wonderful. Information is key. Ladies and gentlemen, so now just a quick one. Yesterday we had introduction to roadway network components, parameters impacting road network conditions, resilience, and sustainability, history of pavement design theories and their impact on roadway conditions. We had discussions, questions, and answers, and yesterday was the opening ceremony. Today is going to be a very beautiful and wonderful day. May I now invite to the stage for his citation our lead speaker for today, Engineer Dr. Patrick Amoah Becker. You can come up stage now. His citation is on page 10. I'll quickly go through it so you know who will be taking us. Just stand and face. I'll read. Now, the citation of a brief of Dr. Patrick Amoah Becker. Engineer Dr. Patrick Amoah Becker is a chief civil engineer with specialization in geotechnical, pavement, structures, and transportation engineering. He also has specialty in transportation economics and project management. He is a consummate public administrator and has risen within the civil service ranks of Ghana. Patrick has over 21 years post-qualification experience and is a registered professional geotechnical engineer in the state of Texas, USA, a member of the Order of the Engineer USA, and a fellow of the Ghana Institution of Engineering. He is currently the Vice President of Ghana Institution of Engineering. He is also the Vice Chair of the Education and Training Committee of the Engineering Council of Ghana. Additionally, he is a member of the American Concrete Institute, where he serves on various committees. Patrick serves as a reviewer for various international journals. Let's put our hands together for him. Patrick obtained his doctorate degree in civil engineering from the University of Florida, USA, in May 2013. He obtained a Master's of Engineering in the same field in August 2009 and a Master of Arts in Economics in May 2013, both from the University of Florida. In July 2022, he was awarded a Master in Public Administration by the Ghana Institute of Management and Public Administration, GIPMA. In June 2002, he was awarded a Bachelor of Science in Civil Engineering from the Kwame Nkrumah University of Science and Technology, Kumasi, Ghana. Patrick has been working at the Department of Feeder Roads, DFR, in Ghana since September 2003. He is the Agency Implementation Team, AIT, head at Ministry of Roads and Highways for the ongoing World Bank funded output and performance-based road contracts in the Bono East and Upper West regions of Ghana. He is also the National Research Coordinator at the Ministry of Roads and Highways and has been spearheading research activities in rural access and transport. Patrick was appointed in September 2017 by the International Roads Federation, IRF, to serve as its Western and Southern African Regional Manager. Let's put our hands together for him. He is an adjunct senior lecturer at the Kwame Nkrumah University of Science and Technology, where he instructs foundation engineering and design and transportation economics and finance courses, both at the postgraduate level. He also is a fellow of the Transportation Research and Education Center of Kumasi. Furthermore, he is a fellow of the Regional Center of Energy and Environmental Sustainability at the University of Energy and Natural Resources, Sunyani, Ghana. Ladies and gentlemen, now we shall be having the Superpave and Balanced Mix design to be taken by Engineer Dr. Patrick Amor Becker. Let's put our hands together for him.
Thank you very much.
You can use this.
All right. Thank you very much, and good morning to you all. Indeed, I'm elated to be here. I think yesterday, Prof set the ball rolling, and so I'll continue today with Superpave. But just a little bit of a joke, you know. When I was in the US studying, the Americans called my name Bikoi. Bikoi. Then today I've had a new name from the Nigerians. Just so it is Bekwe. Bekwe. It's our tree account phonetics, mainly talking about a warrior, a fighter. That's the meaning of my name, Bekwe. So, you know, in America, they say, oh, Bikwe, Dr. Bikwe, Patrick Bikwe. And I had to accept it as my name. That's just by the way. So we are going to talk about Superpave. Since I'm in the institution, I think it's also better I say greetings from the Ghana Institution of Engineering. We've been having very good relationship with Nigeria Society of Engineers for a very long period, and I became the vice president this March. I think you were around, Engineer Bola, and so we look forward that the next 2 years our collaboration will be even greater going forward. So I don't know whether you can put a presentation for the next. I'm giving how many hours? 2 hours? I'll try and make it short. So when I was coming, I was preparing exercises. I thought it was a small group for us to do and to discuss a lot of issues, but yesterday I had to change my notes, and thank you very much so that I fit in to deal with the issue. You know, once a teacher, always a teacher. But how many of us have heard about Superpave? Just heard about Superpave. Okay. All right. So I'll know how to approach it. Someone will wonder, why is a Ghanaian talking about Superpave? In Ghana, are you using Superpave? We'll answer that later on. Can we go to the presentation? So even before whilst we are dealing with Superpave and a balanced mix design, I think the premise and the challenge in Africa is that we have all these institutions in roads and all those things, but what we lack is data. So we've not been able to collect a lot of data about our environment, about roads, about a lot of things. So I'm sure all of you have done ASHTO, pavement designs. You are aware of it. But what is the premise of ASHTO? It's premised on testing and data collection. And so even before I start, when all is said and done, I believe we need to, as Africans, and this is something I've been talking about in Ghana, we need to start thinking about setting the right institutional framework. The right institutional framework to deal with effective data collection that will tell us about our network, its performance over a period. Sometimes in Africa, we do not see data as important. We don't collect data. We are not intentional with data collection. We are, some of us have been doing laboratory tests for a very long period. But if we ask you for the past 10 years, where's your data and what have we learned from our data, we cannot we cannot say anything about that. And that is challenging. And now with AI and all those things, I believe we need to start thinking differently and look at the institutional framework that we need to ensure that we will get here. So the people who have gotten here, Prof, it's because they were intentional and they did proper research and data collection. And when they were reading my listing, we started something and under the African, I don't know whoever heard about the African Partnership research. So it was more of an Africa and Asia recap. And that's Research for Community Access Partnership. I think you can Google it, Research for Community Access Partnership. And we're looking at how we can use applied research to influence the way we do things in Africa and Asia. And I believe it's this direction that we're trying to follow. And Nigeria, Ghana, wherever you come from, this morning we were discussing about the challenges that we have in our various countries, in Egypt, Nigeria, and I think it's the same. It's the same. So I'm going to talk about Superpave, but this is really what I want to leave with. How do we, sometimes we are saying the old people, but actually we are the old people who can bring change. And it starts with, and thank you very much for, you called it a name, but Engineer Ewuba, it's more about, more than motivational. That is something that what we just said, the right information, getting the right information. So let us be, and it starts with us now. In our small organization, how do we ensure that we collect the right data to change this thing? So let's go to the next slide. So okay. So Superpave, a little bit about the history of Superpave. So the Federal Highway Authority, in somewhere in the mid-80s, actually launched, established the Strategic Highway Research Program. And it devoted 150 million research, mainly to improve the performance and durability of highways. Would we do that? That's just right away. And in the area of asphalt, they look at maybe how do we look at one, traffic loading and environmental conditions. Two, the binder, and yesterday we talked about the binder and how we miss asphalt. So that was the thinking, that how do we improve the performance? Because our pavement or our asphalt is going to perform in an environment. How do we simulate or understand the environmental factors on our asphalt? How do we understand the properties of the binder and also then the properties of the mixture? So that's the big distance. So they wanted to produce what they call the superior performance pavements. Superior performance pavements. So that's why we call Superpave. So the superior is just the acronym there that has been used to perform this thing. So what really changed is, I'm sure most of you are used to the Marshall mix design and the HVIM. HVIM, then Marshall-Mix design. But then they introduced the gyratory compactor. I'll talk about that later on for Superpave. I should point this way. Okay. So they developed what we call the PG system, performance grade system for hot mix asphalt. And before I go ahead, I don't know whether yesterday you talked about it. When I returned from the US and I was in a meeting in my office and I was talking about asphalt, and the old people, they were all watching me. And you are working in feeder roads and you are talking so much about asphalt. What's wrong with you? So, you know, we use bitumen. The American call it asphalt. So I don't know whether yesterday you brought that thing up, because sometimes it's confused for us when we say asphalt. They are talking about the concrete, the mixture. Okay, it's the same in Nigeria. It's the same in Nigeria. So I was actually talking about bitumen, the binder, but everybody in the room was thinking that I was talking about the concrete, the mixture, the American way of calling the bitumen. So when I say asphalt, know that I'm talking about bitumen. Okay? So if I need to draw the distance, or use the binder instead, or this thing. So let's try and understand the Superpave mixture. I've talked about this. Well, so it had certain components, and the components mainly, we wanted to understand the binder. I think I've talked about it, and the volumetric properties. I'll talk about it. So, what about the binder did we want to know? So remember, what do we do in Marshall? You know, in Marshall, what are the tests that you typically do when you are doing on your bitumen? Stability, flow, penetration, yes. Now, just think about the test, the meaning, and what do we want to simulate? You realize that this test it gives you, yes, an idea of the temperature that it can resist in a way, but what they sought to do under Superpave was they wanted a binder that can withstand high temperature, which will affect ratting. Yesterday he talked about it, and also very hot, cold temperature. So just by looking at the binder grade, we'll be able to tell the temperature and the various temperature, whether it's in cold or what, in warm temperature. So they developed what we call the performance grade system, and I'll explain that going forward. Okay, so what is the PG system? So the PG is the performance grade, and here we are simulating the environment. We are simulating what? The environment. So the performance grade, now the first one after that is the average 7-day maximum pavement temperature. That's the average 7-day maximum temperature in degrees Celsius. Then the next one, that's, you see in this case, is 64. Then the next one is minus 22, which is the minimum pavement temperature. The minimum temperature. And these are typical ranges that we've given the possible, and there can be various combinations of it. I'll explain that in a minute. Now, so how do we come out with? So the highest temperature typically and this they did it through research. It's pavement temperature, not air temperature. So you cannot just use your air temperature to determine it. You can have the air temperature, but what is really affecting? So they used that 20 millimeters, and actually went around, looked at various asphalts. What is the temperature? When the air temperature is maybe 32 degrees, what is the pavement temperature? Okay, and they looked at 20 millimeters below the surface of the asphalt. Then they look at the low temperature also at the surface of the mixture. Now, this is, you can look at this link, that is, you can use that. They've collected a lot of data to determine the pavement temperature, which is a function of the air temperature, the depth, the climatic conditions, latitude that we are dealing with. So this is a typical example of how to determine the various pavement temperature and that you'll be dealing with. Now, so let me go back again. What we did, or they did, was that based on, you see the combinations there, you see the various temperature, 46, 52, 56, 64, and you can see the increments, 6 degrees. So depending on where you fall, because there can be so many different temperatures. So they had this temperature gradation at 6 degrees interval. So for example, if your pavement temperature is around maybe 48, then you will typically choose grade 52 for the high temperature. And then there are various combinations of the minimum temperatures that, and you realize that the increment are 666 degrees Celsius. Please, I hope you get a picture over here. Very good. Now let's now look at the binder. So we are now dealing with the asphalt, the binder. Okay. One of the things that they looked at is the rheology, basically the flowing properties of the binder, then the in-service property, and how the environment affects it. And when we are talking about the environment, we are looking at the short term and then the long term. So you agree with me that when we deal with asphalt, or bitumen, what happens when it comes into contact with the environment? Just is the same for Masha. Please, your thoughts. Oxidization. So the presence of air, or even you can say moisture. To an extent, air and moisture will oxidize it. And so we will want to simulate the properties within the short and also the long-term oxidization. And that's what they did going forward. So now let's look at the test that they did. So in terms of the rheology, they looked at the rotational viscometer. Remember, someone talked about viscosity tests. You do that in your Masha. Am I right? That's what you said. So then they looked at the dynamic shear rheometer. I'll explain that a little bit. Then they looked at the bending beam rheometer. So it's the asphalt, the bitumen, the test on them. Then they did the direct tension test. Then they looked at the aging property when it comes into contact with air. Go back. When it comes into contact with air, it oxidizes, as you rightly said, or it ages. And so they looked at the short-term aging, and then they looked at the long-term aging. So I know some of you, this will be made available again to you, so you don't need to take pictures. I'll make the slides available again to you. Now, basically, this is what we are dealing with. You are dealing with a spectrum of tests that you will conduct on the binder. You see, I'm still focusing on the hot binder. And it's dealing with a lot of issues. Drawing construction, okay? Then short-term, okay, performance, and then long-term performance. So all these tests that you'll be dealing, they have meaning. Sometimes we just copy, oh, this, we should do this. But why do we do this test? And that's what I'm trying to do. So one of the tests that you'll be dealing with, I've talked about it, the rheological test. So on the top right, this one, I'm sure you know it's, this is the viscometer test that you've been dealing with. I talked earlier on about the bending beam test, if you go back. So these are the tests that you are seeing: the viscometer test, the shear tests, and the bending beam, then the direct tension test. So that's the same test that you are seeing over here. The top, the one in the middle here, it's the shear, okay? All right, then the bending beam test that you will deal with it. But in all the tests, one of the things we do is we look at the non-aged. That's when we've not introduced air and all those moisture. And then we look at the aged. So the age is the rolling thin film oven test. We use that to age your binder. And then we look at the short-term aging. And then for the long-term aging, they introduce what we call the pressurized hot asphalt, the PAV, the pressurized asphalt aging equipment. Now, it's for long-term oven, so they pressurize it. That's the equipment over there, and that's what they use to simulate the test over there. So they send the asphalt to these various conditions, and then they test them and look at the properties of the asphalt over there. So let's now look back. You conduct some tests, but in all the tests under Superpave, you look at non-aging and what? Aging. And then aging, you are dealing with the short-term aging, and you are dealing with what? The long-term what? Aging. Please, is that well understood? That principle is just, I try to put a lot of things on the page to simulate it. So for the asphalt, based on the test and in the next slide, these are the possible combinations. Remember, we saw based on the various temperature. So if I'm in Ghana and I say PG 6428, what does PG 6428 mean? What does it mean? Let's understand the nomenclature. Okay, I don't want to hear from, I want this side. Just 1 minute. I think you are an asphalt person. Just to get whether we understand the concept. Anyone from here to help me? 6428. So minus 28 is the lowest, and the 64 the higher temperature, 7-day maximum distance. So, and remember, it depends on, in the 7-day, we are looking at the asphalt temperature. Remember, all these are in degrees of Celsius. Okay. So, at least, if we live here and we ask you to, you see any PG grade, you understand what it means. Please, is that clear? Okay, so can we go ahead? So this is just to emphasize what we are dealing with. In all the tests, this is looking at the rat resistance, the high temperature, and also what? The crack resistance, okay? The cracking resistance, we'll come to the. So typically, this is not quite clear, but this is how a PG grade specification looks like for the binder. Once again, for the binder. So you realize that for each and every performance grade, you are dealing with the original properties, that is the non-aged, okay? Then you are dealing with the aged. Remember the age, we are dealing with what? The short and then the long term. Please, is that well understood? And that's how it's reported. So for every grade, there are limits. And this, as I said, this is based on a lot of testing and research that they came out with these recommendations. Thank you very much. Yes. You say? All right, so you realize these are the properties. So the original binder, you do your flash points, am I right? Is it showing? Yeah. Then you do your viscometer, and you do your dynamic shear rail meter. Can you see that? So this is for the original binder. Okay. Then you do the rolling thin film oven test, and this is short, am I right? Short term, am I right? So that are these are the properties, the dynamic shear, maximum loss, and all those things. Then you now pressurize it. That's the pressure aging vessel, the residual, and that's the long term. So the long term, these are the properties, the creep and all those things. Please, is that clear? Perfect. Good. So this, I'm only showing for up to 64. There are a lot of sheets that will show for the various properties what you are supposed to get. You got it? Thank you. All right. So remember, this research was not done in Africa. It was done in the US, and so they were able to establish for various climatic zones and area the typical pigeons that you use. So if you know US, whether you are in the West Coast or you are in the East Coast, the South or Middle, these are the typical ranges. So I was in Florida, and we were typically 64, 76. You know, our temperatures will typically go high, and so we will have very high, and ratting was a major problem for a lot of our asphalt. I have a feeling, and the few that we've done, if I'm right, we normally adapt that of Florida in Ghana. And I believe Nigeria, because you also have very high temperatures, and your temperature, low temperatures, you don't have very low temperatures, but you still have very high temperatures. So if you are to adapt, these are things you need to think through in adapting a particular PG grade. All right. Well, so I talked about data. I'm just re-emphasizing the need that they were intentional. They built, and tomorrow when we look at MEPG, it's once again, it's about data. They've built a lot of stations. They've been collecting this data, and they still do it. Actually, under the long-term performance pavements, they're still collecting data and dealing with it. So Now they are dealing with long-term LTTP. I'm sure most of you are used to the long-term performance pavement, and they want to build pavements that will last 75 years minimum, 100 years and above. But that will last a long time, at least with minimal maintenance, So, so we've looked at the binder. Now, we want to look at the aggregates, okay, before we go to the mixture. That's what we are doing. So, now, the aggregate properties under HVIM, Marshall, what test do you do on them? Yes, so, no, let's say them, just we are learning together. Abrasion, LA, abrasion, ACV, yes, flakiness. Oh, I thought what Prof said yesterday would be the first. Do you remember yesterday he showed us something? See, it's common whether you are in concrete, yesterday he told us whether you are in concrete or whether you are in soils or whatever is the commonness. So I thought that would be the number one. Anyway, yes, so the test is basically the same. Now, but there were issues about the limits. So they came out with what we called the consensus aggregate properties. And these are the consensus aggregate properties. The fine aggregate angularity, I think then the clay content, then the coarse aggregate angularity, then the flat and elongated pieces. One for the coarse, this is for the fine. Then, depending on where you are, because they said this is the source aggregate property, it's not constant. So they looked at toughness, soundness, and deleterious material. And like you said, gradation was common for everyone. So these are the three main aggregate properties that we looked at under Superpave. Coarse consensus aggregate properties, source aggregate properties, and gradation. You can say two because gradation it's so. Well, the properties and the test I'm not going to go through, but I believe most of you know when it comes to early aberration, we know how to determine early aberration. And you'll do that. For coarse aggregates, they have some steel bores, am I right? What is the standard? About most often 12, am I right? You put certain sieve size of aggregate, you roll it over some revolutions, and then you weigh the aggregate before and after what has been lost, and you're actually looking at the percentage that has been lost. And what does it simulate? Early aberration. In real life, what are we trying to deal with? So if we have two aggregates, one has an early loss of maybe 6%, and another one has 12%. What is the difference? Sometimes, we are bugged into the tests, but we need to understand. My professor always will say, what is the meaning and what is the implication? And it's very, very important. So what's the difference, 6 and 12%? You are saying wearing, okay? Yeah, to an extent, yes. No, please, someone say something in the middle. I want to repeat yourself. Okay, so the toughness and the abrasion. So if you are using an aggregate that has a very high abrasion, when it comes to performance, you have problems. Okay, so these are things, and that's why there are limits on the use of it. Angularity and all those things. I don't want to spend time, but these are common tests that we know. But as engineers, let's think about them and the implication, so that, especially those of us who approve, when a contractor comes to you and say that, oh, the limit is 12%, but 14 is close to 12. You can even explain the implication. Sometimes people in the lab don't understand the importance of their work very well and what they do. They think it's just numbers, and it's not numbers. Every number has a meaning. So the next thing I want to talk about is the sieve analysis. So the sieve analysis is our normal sieve analysis, but in asphalt, they use the 0.45 power gradation curve. So who knows about the 0.45 power gradation? We use it common, even this thing, but it's found to give you the maximum packing density if you're on that straight line, okay? So from packing theory, it means that more aggregates can fill the voids, everything, and it can be the densest, okay? So, well, I'll come back to this, but you see the line there, the straight line here, at the top right. So that is the 0.45 power gradation. Now, what they did under Superpave, they defined certain things. So I'm going to go through for the aggregates. One, they gave some designations and aggregate designation, mainly based on the nominal maximum size and the maximum size of aggregates. Please, what is the nominal maximum size of an aggregate? Nominal maximum size of an aggregate. We see that a lot in documentations when we are doing, use the nominal maximum size. Please, are we following? So what is the nominal maximum size? Or I'm not supposed to ask questions. Of an aggregate, whatever. When we say nominal maximum size, just what comes into your mind? Oh, okay. So I am not, what does it mean? Or when I say 25 millimeters, what is the nominal maximum size? Okay. All right. Okay. 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 You remember yesterday, Prof showed us the sieve sizes and the openings. So I bring some aggregate over here. We pour it, we shake it. Okay? When we shake it, and you do your sieve analysis, can you determine the nominal maximum size from it and the maximum size? Okay, so how do you determine it? No, okay, now let me explain. So I'm giving you a general definition. So, but it varies from standard to standard generally. One, so the maximum size of the aggregate is the smallest sieve size. The smallest sieve size, that 100% of the aggregate passes through. Please, are you getting me? So you know you can have big, 100% are going through, 100 are going through. But the smallest one, that 100% of the aggregate passes through is what? The maximum what? Aggregate size. The nominal maximum aggregate size is also generally, it tends to be the next after the maximum aggregate size, but typically retains, and it varies, 5 to 10%, sometimes people say up to 15%. 5 to 10% of the aggregate. So you realize that there is another sieve under it that will retain something, and it retains to 5 to what? 10% of it. That's what I'm saying, it varies from standard. That is the nominal maximum size. So when I'm saying the nominal maximum size is for example, 19 millimeters, you should know the type of aggregate that I'm thinking about. And when you are going to buy, what you are dealing with. Please, is that clear? So now we know the difference. So they had these classifications that they were using, 1 inch, 3/4, I'm saying the American way, but okay.
Just a minute. Ladies and gentlemen, the president of the Nigerian Society of Engineers, Engineer Margaret Aino Oguntala, FNSC. She's here. Madam President, that's the Vice President, Ghana Institution of Engineering. And all right, thank you for coming, ma. So we have 15 minutes. Then after to finish, we'll go for tea break. Come back. Okay, you still have, it's still lengthy? No, I still have. Okay, so in 15 minutes.
Okay. All right, so we can go to the welcome, ma'am. So, please, this concept is very key. Now, beyond that, they came out with certain control points so that when you plot your gradation curve, it should fall within certain control curve. And then they develop what they call the restricted zone. So the restricted zone is places that your curve should not go through. And once again, this is based on research and data that they've collected over a period of time. So for example, I'm using 37.5 Superpave gradation curve. So this is the example that I'm using, but you can have the 19 millimeter, or you can have the 9.5 millimeter Superpave gradation curve, and the control points and the restricted zones are different. So in this particular case, you see those points here are the control points. That means your gradation curve should fall within those control points. Then the small envelope, you see in at the top right, that small curve is a restricted zone. Prof, my current reading is that now people are disputing the restricted zone, that it's not necessarily, you can pass there and can still perform very well. But generally, this is the guideline that we should still use the restricted zone. Ratting, yes. True. Precisely. So I'll talk. Thank you very much. So the point I'm trying to make is that whatever gradation that you give, you should ensure that you avoid the restricted zone, and you stay within your control points. Okay. Now, this is just a guideline on how to, and I'm not going to go through, how to do, those of you who are in the lab, how do you do a Superpave aggregate gradation? And this procedure has been given. You can look at it. It can help you in future. Well, so what we've been able to do, let's step back. Now we understand the binder. We now have an idea of the aggregates. And we just ended with the aggregate gradation. We said that for the aggregate, there are 3 key properties. What were they? The first one is what? The consensus. Do you understand? Do you remember? The second one, the source. And the third one, the gradation. And in each one, there are certain tests that we are supposed to do. I ended with the gradation, and the gradation, I emphasized that under the gradation, we have certain control points, and then we deal with also the restricted zone. When we come to the volumetric mist, I will show curves. Typically, what you do, you don't do only one mist. Typically, you do 3. You do 3, but 3 is the minimum. If you can do more, it's better. If you can do more, it's better for a particular asphalt mix. So now let's go to volumetric. This was not part, the details was not part of the slides, but yesterday, when there was a question on asphalt and the voice filled with binder, in the night I started thinking through, and I modified the slides to deal with it. But perhaps this is what we are dealing with. Aggregates. Prof yesterday gave us a very good picture. Depending on whether you are dealing with concrete, cement concrete, you are dealing with soils, or you are dealing with asphalt. But the story is that we have your aggregates, you have your binder, but for asphalt, some of the binder goes into the aggregates. Okay? So all that he was trying to tell us is that depending on your voids in your aggregates, if you think the binder is only going to coat around your aggregates, you can end up with a lean, let me call it that way, a lean mist than expected. That was the story. So you have to account for the absorption into the binder, into the aggregates. Thank you. So I'm going to go through a little, I'm not going to go into the details of the volumetrics, but some terminologies, and later on, they took my 40 minutes, and I'll get it right, that's just by the way. So 10 minutes, I'll make sure, I'll not finish the volumetrics, but I'll bring the key points, and maybe we can continue. So, I don't know whether it's clear from your end. So I've given some terminologies that we use when we are dealing with asphalt mix design. That's the volume. Now we are combining. We are not going to go in through the distance, but I will be coming back to this page as we go forward to explain certain concepts. But so this is the volume and mass relationship. I think Prof showed this yesterday. So when we are dealing with asphalt, we are dealing with one, the aggregates, the fine aggregates. Then there is a binder that is absorbed into the aggregates. And then there is the binder that is actually used for coating. And then there is air voids. So all this volume, we need to calculate them when we are dealing with the mixed design. So our job is to calculate this. So VA is the volume of voids, okay, or air, volume of air. Now, there is VMA. So when you go back, I've defined VMA, voids in mineral aggregates, okay? And you see VFA, voids filled with what? Asphalt. You see, it's down there. We have voids in mineral aggregates, voids filled with asphalt. Then we have the voids, then all those things. So for the purpose of my 10 minutes, what I'm going to do is to explain, so figuratively, I mean, from the diagram, you know what is the VMA, okay, voids filled with mineral aggregate. And this, you can do a lot of computations based and determine a lot of the properties based on that. But what I've done is give a very quick snapshot of how to determine the various properties. Are you following? How to determine the various properties. So, because of time, I'm not going to go through this, but for each and every one, who knows about the Rice test? Rice test. You should know it. You do right to determine the maximum density of your asphalt. You do it also, yes, in Masha. That's how. So whatever it is, it was made by Rice. So we call it Rice test. Basically, the properties and the various determination are down there. So that's the volumetric, and I've explained how to determine all those various properties. I will want to end here for now. But a quick one, before we come to the Superpave design, what I've shown here, you see the subscription. So I've given, where is it? Down here, you see, if you say JMM, okay? So, yes, precisely. So it's, you say the last one first, the last subscript, before you come to what? The first one. So let's give an example here. So here is JMM, maximum hot, mixture hot, gravity. So you can use the subscription there, and it's so easy. You can easily, that's why I've given you this sheet. And when you go forward here, then you can then explain all those calculations, the volume of voice, the maximum densities or effective asphalt content. If you are doing the mixed design, you can do that. Now, what we're going to do next is how do we actually do the design? So what I have done so far, one, we are saying that we need to know, once again, we need to know the binder properties, the aggregate properties, and we just started the mixture, but I just gave you the volumetrics of the mixture. We will now go to the design procedure, and then we'll end it there. On that note, I want to thank you for this opportunity.
Thank you very much, Dr. Patrick. You will come back. You have your time back. Don't worry. Ladies and gentlemen, may I now invite to address us the 34th President of the Nigerian Society of Engineers and the first female president in our society's 67-year history. Please make welcome to the podium Engineer Margaret Aino Oguntala, Fellow of the Nigerian Society of Engineers.
He almost forgot to do his job of gentleman. He thinks as an engineer first, and then he has to take care of the ladies when they come up here. Good morning, everyone. I'm sorry that I had to barge in. I had a 10 a.m. meeting, and then I have another one waiting, but I had to just come here. Because last year, I was very, very intrigued with what happened here. And from the report that I got yesterday, I was made to understand that this is even a bigger workshop than that of last year. So I needed to come and see for myself. And I'm very happy with what I see. Because the Nigerian Institution of Highway and Transportation Engineers is one of the very, very important divisions of the Nigerian Society of Engineers, and one of the most responsible, if I must say. The division has taken the matter of continuing professional development very, very seriously. And you do not just do it amongst yourself, you also collaborate with international bodies to ensure that your members get the required continuing professional development points for upskilling and competence and all of that. And I must congratulate you. Please give a round of applause to yourselves, the NIHTE. Now, I'd like to inform everyone here that the institution is just way ahead of some others, but I think it also knew that the NSC at the headquarters was working towards making collaborations easier. About 2 weeks ago, the NSC got ISO 9001:2015 certification. And the certification is in the areas of membership development, continuing professional development, which you are doing now, stakeholder engagement, engineering education, and advocacy. So that means we are on the right path. And it also means that we have a lot of work to do to continue to earn the certification. So I just say that the workshop that we're having today, and which started yesterday, on managing road infrastructure assets for sustainability, is just one of the very good things that you are doing and you must continue to do. So much more now is expected of you to ensure that we remain where we ought to be in terms of standard. And when it comes to standard and development of codes, I also expect this year to receive whatever you have done to ensure that the standard is maintained in your institution and within the sector in which you practice. So on that note, I'd like once again to congratulate all of you for being part of this workshop. And I'd like to thank our partners. Thank you very much. Your expertise, your knowledge that you have come here to share with us is well appreciated. And we assure you that we'll continue to work very closely with you to ensure that the transportation sector is well maintained with high quality and with experience and the required expertise to maintain the proficiency and competency of all the workers in that sector. Thank you very much, and God bless you all. So I'm supposed to have a meeting at 11 a.m. at the Federal Ministry of Works with the directors, an interactive session. But I understand most of you are here. Is that correct? Directors are not here. Okay. So if they were, I would have said, well, maybe we should just have the meeting here. But since they are not here, I'll just proceed to the Federal Ministry of Works. Thank you.
Just to add that we also have some international participants.
17.
No, international participants.
International, yes, I know.
Okay, that attended. No, not the source person.
Okay, so I've just been made to understand. That's why it's an international workshop. Yes. So you just told me that there's quite a number of international participants at this workshop. That's very commendable. And it also shows your reach as an institution. So congratulations again. Thank you.
All right, so Madam President, we'll have a quick photograph with our dignitaries and the Executive Committee of Nigeria Institution of Highways and Transportation Engineers. Official photographer, please, set up. Thank you all very much. Due to the exigencies of the office of Madam President, she will have to take her leave. Ladies and gentlemen, now we go to our coffee and tea break. We shall have it very quickly as we have the next presenter waiting online already. Please hold on, just listen.
Ladies and gentlemen, please, we'll go for tea break. But the next presenter is going to be talking to us from Thailand. He's already waiting on the Zoom to speak with us. And we're actually trying to see, do we need to appeal to you to have him before even going for the tea break? But I think we have about 15 minutes or thereabout. We just have 10 minutes.
Yes.
We made him know that he will need to talk to us starting 11 o'clock. You are with me? He needs to talk to us starting by 11 o'clock. Now we just have about 9 minutes to 11. I don't know if I need to appeal to you. Let's have him, since he's already on Zoom waiting. Let's have him. We'll listen to him, get that lecture properly assimilated. We can't change the timing. Here it's still in the morning or so, but it's already in the night in Thailand, I'm told. So if we can just be patient, have him, immediately he's through, we will now readjust the tea break. Then come back and have our lecture, the continuation of what Patrick couldn't finish after that. Is that okay by us? Is that okay by us? We are democratic, so we want to take that permission from you. So I think what we need to do now is we just have about 5-10 minutes. You just stretch your legs, please, within the hall here. Just move around, stretch your leg, socialize, and exactly 5 minutes to 11, I will expect us to be seated so that we can start that lecture on the Zoom. Is that okay?
Yes.
Thank you very much.
Thank you.
I think it's better.
Yeah. So on that note, please ensure you get the phone numbers of 5 persons that are not in your organization. Oh yeah, let's start moving now. Just greet 5 different persons from different places. Not within Federal Ministry of Work if you are from Works, not within RAMP if you are from RAMP, not within FEMA if you are from FEMA. So let's do that in 5 minutes. Thank you. All right, can we now have our seats? I believe by now you have your 5 contacts. Let us have our seats now. May I request the media to please switch to our presenter on Zoom. All right, ladies and gentlemen, let us please be calm as we now take the next presentation and training from online. The topic for this presentation is Roadroid presentation on data collection techniques, and that will be delivered by Mikhail Kekbek. He is from Roadroid, Thailand. Roadroid is actually USA, but he is in charge of the Thailand Roadroid. So please, let's put our hands together for him so he can hear our clapping online as we now have him. Thank you. So Mr. Mikhail, it's your time.
Nice to see you all. I've been listening in a little bit before this. Now I notice we have 2 problems. The first, I cannot share my screen. So that means it will be a bit of a problem to do a presentation. And secondly, I hear myself as well on the, so if the technical problems can be solved, it will be easier for me to do a presentation. Okay, I will then try and send the presentation as the latest instructions. So if you didn't have that much of a tea break, you can probably have it because it's going to take a little bit more time than to set things up. Sorry about that. Okay, so I have now sent the presentation. Okay, great. I for now see the presentation. So if someone, okay, confirm. Someone will change the slides. Thank you very much. Great to be here at this seminar. As you were told in the introduction here before the tea break, I am contacting you from Thailand. However, Roadroid as a company is Swedish. I will come into that a little bit more. But more importantly, why we are here presenting to you is because I think we match one of your objectives for this seminar, which I have quoted here, state-of-the-art methodologies to inspect roadways and collect data for evaluating road network conditions. So I'm going to talk a little bit about our solution to do just that. And again, thanks for being here, especially to engineer Isa, who we have been working together with for many years now, and it's always great to be part of any of the seminars and events that you are hosting when organizing. Next page, please. Yeah, this is just a short introduction about me. I'm a global project manager for Roadroid, and as such, I handle a lot of our different global projects. We are, next slide, please. Yeah, you can take the next one again. So I will get straight into what we do at Roadroid, what our solution is. So it's road surveying, and it's based on Android smartphones. And connected to that, we have a cloud service where you manage all the data that you collect with your smartphone. We are an IQL3 device, response type. Those of you, I guess most of you are familiar with road surveying. You would know that there are different IQL levels. We will come in a little bit more in detail into that. We are, anyway, IQL3. With IQL3, we record, the app records IRI values, and we have a GPS coordinate matching that IRI value for every second. We take photos or videos. You have a choice to do one of the two. And the data is collected on the phone. You don't need an internet connection to collect data, but you collect the data, and then you, when you have an internet connection, you upload it to our
Recording in progress.
And in our road data management system, you can view the data and analyze it in different ways. And you can also export it via an API. Next slide, please. This is just another way of showing what I just said. So it's a very easy setup with the smartphone. You have the possibility to do a calibration procedure. You do your survey, you upload your data to the cloud service, you view it, you do different kinds of analyzing and inventory. We have an AI tool, which I'm going to talk a little bit more about. And you can also extract all the data from our system. Next slide. So Roadroid compared to other systems, I hope while I'm continuing my presentation that you will see these main benefits that we promote compared to other road surveying systems that are out there. We are low cost, license based. You pay a monthly license fee, and it depends a little bit on how many units you have and for how long time you subscribe to a license. But the low cost structure gives you a possibility to have many units. It's easy to use. These days, everyone knows how to use a smartphone, to download an app, to use an app. The interface is easy to understand for everyone. And this also means that you can use it often. It's portable. It's a smartphone. You can bring it anywhere. You can use virtually any car. Some limitations, I will get into that, but in essence, you can move the survey equipment, the data collection equipment around much easier than if you would have a specially equipped car with different kinds of sensors on it. So all this allows you to do more frequent surveys and to also, as mentioned, integrate with your AI. Short on Roadroid's history, which is this slide. We've been around for a while using different technologies, but as you probably understand, our breakthrough came with the use of smartphones in 2011. And currently we have business in about 40 countries across 5 continents. And we also continuously do research and development with universities all around the globe. One in Nigeria for the moment, I think, for example. Next slide. Some reference projects. As mentioned, as a Swedish company, of course, we have worked closely together with the Swedish Transport Administration Agency for many years. We have done quite a lot of work in the United States, mostly on county level, and the road networks they are responsible for. We work with larger organizations like the UN, UNOPS, the Asian Development Bank, the World Bank, of course, and those projects can be take place in, of course, many different countries in the world, mostly developing countries. Then, next slide. Indonesia is another example. New Zealand. On the African continent, we have worked in several different countries. For the moment, we have a large contract in Uganda. It's no longer with UNRWA, as some of you, I don't know how much you keep track of other countries on the African continent, but UNRWA is now integrated into the Ministry of Public Works, I think, or possibly if it's the Ministry of Transport. But and we also work with the Roads Authority of Namibia. A little bit more about the technology, the IRI. We use the accelerometer of the phone, and the accelerometer is capable now in most phones of analyzing 200 vibrations, which gives you one value per section. So that is the raw data. Next slide. And that raw data through our software, through our algorithms, is then translated into a value that correlates with the International Roughness Index, which I also think is something most of you are familiar with. And class 1 would be precision profiles, laser profilers. And that's the most accurate way of measuring IRI, of course. And again, as mentioned before, we come in the category of class 3 together with ROMDAS and other bump integrators, and other solutions that are response type 3, in many cases using an accelerometer of some kind. Class 4 would then, of course, be the subjective ratings. Next slide. I will just touch on this briefly. If you have any specific question around this, we can take it in the Q&A session later. But we have 2 different ways of measuring the IRI. And the EIRI, the estimated IRI, is what most of our customer use. And that's mainly because it has a built-in speed compensation. Can be difficult sometimes to keep a consistent speed. It's preferable to do that even with our system. But if not, we have a speed compensation built in. And it's also sensitive for typical damages that you want to track during your surveying, like potholes and rough texture. The CIRI, which is also used, the calculated IRI, is more in line with the theoretics of measuring IRI and uses the quarter car algorithm. So 2 different ways, a little bit depending on what the customer wants to use. Next. To get better accuracy, as we are an IQL3 device, some limitations to that, and that can be, the accuracy can be improved by doing a data collection unit, the smartphone, before you run it on a specific section, and that is done by running the system to a known section where you have an IQL1 measure device who have measure the value. So just to let you know, there is a way to calibrate and fine-tune our system. Next. Some important preconditions, which is based on what our system consists of. You, of course, need a vehicle. Even bikes are used sometimes, actually, but of course, normally a car. And we have some different standard vehicles to choose from. But the most important thing is to have a car that has a good suspension, not a sports suspension, for example, and to make sure that it's properly balanced, using the right standard tire pressure and so on. And all of this is, of course, to avoid unnecessary vibrations coming from the car and not from the road. So that's why it is important to have a well-maintained vehicle. The phone, use preferably a higher-end phone. Even though most phones today have an accelerometer, you still need to have a proper phone. And also, if you can, even if we have compensation for it, try to keep consistent survey speed. And also connected to the phone, it's important to have a steady phone mount, not just an ordinary phone mount. But, and again, that is to eliminate unnecessary vibrations. Next. Yeah, and this is from the app interface. So when you start your survey, you can see that you can pick up, you can pick different survey. You can choose to just record IRI value. You can survey with photos or survey with photo or videos. And yeah, this is basically what it would look like on the screen when you're out surveying. Phone is always placed on the windshield of the car, if I haven't mentioned that before. Next slide. So once you have collected the data, as mentioned, and you can do that without the internet connection, without any SIM card, anything like that. Go back to your office, make sure you have a stable internet connection, and then you upload the data that you have collected. And within 10-15 minutes, it will appear in our cloud road data management system. Next. And once it's there, you can view it. You will have a list of all your files. If we have time, I will show you a little bit of this live online. No, sorry. Of course, I can't do that when I can't share the screen. Okay, so we just have to look at it then in this way. Input history, and you would when you would click on a file on the input history, you can get, of course, more details on that file, and it would show you the different IRI values that are recorded and all the basic data from the survey. Next page. Next page, please. Yeah. And if you would go into the map view, it would look like this. And you would have several different options to how you want to sort the data in the map view. If you want to look at photos or not look at photos. If you want to zoom in to look at in more detail into the IRI values. Next. We do have a simple system to categorize the IRI recorded values, which then would show on the map from green via yellow and red to black, where green is good and black is poor. So that is how you can get a first view of the IRI values, and the photos you take will also be GPS positioned and placed on the map, so to speak. And if we take the next page, this is what would happen if you want to look, if you export the data and you want to look at it in more detail and work with the numbers, so to speak. There's also a possibility to do that. This is from Excel, for example. We also have different GIS formats that you can export the data into. Next. We have a tool in the system where you manually can make an inventory, and it's quite convenient. Quite a lot of our customer uses this. Once you're back in your office, you go through the photos or the videos that you have taken, and you can then map on each photo if you see a drainage condition, a loose gravel, a pothole, or several. I think we have up to 25, 30 different categories that you can use for the manual inventory. Next. And of course, as everyone, we are doing a lot of AI these days, and we have, in our case, the AI is of course to work with image analyzing. This is not for video for the moment, but for recorded photos. And what we can automatically detect with our image analyzing system is dust, if we place an extra camera in the rear window, and corrugations, potholes, and loose gravel. And as you understand a little bit from that list, we are now in the beginning mostly focusing on using our AI for unpaved roads, but there is a possibility, and we have also done some of this image analyzing for paved roads. But this is where as we probably you all know, not only me, but we all know that this is a little bit of where the future is, to work more and more with the image analyzing, automated image analyzing. Next. So for maintenance of roads, of course, one of the other benefits with Roadroid is that it can be used for evaluating performance-based contracts. And I suppose that is something you touch upon during this seminar as well. But I'll go to the next slide to show an example. So this is where in Sweden, where our system has been used for creating performance-based reports. And we then come back to the fact that we can the ease of use makes it easy to use Roadroid very frequently. So this is, if it's not visible, we have measured the same roads since 2019, every month from May, June, July to August. And you can then track the difference between those 4 months and see how the road condition changes, or preferably not changes. In this slide, you can see that there are, in some cases, big change. IRF is part of this seminar. We do a lot of work with IRF Global in different kinds of seminar. I can't show you this example now in detail, but this is also something when we are taking part of PBC seminars with IRF Global. Go to the next page, please. We have done a seminar with IRF Global in Orlando in Florida since 2016. There was a break for COVID, of course, there. But this is also a comparison then to show how you can track the performance of a road with Roadroid and compare it within from different years. And in this case, you can see that if you look at the average EIRI, that this road was in quite poor condition, 2016, 2017, and then it got a refurbishment in 2018, and of course it improved. And then you can see last time we did the survey in 2003, it's still 2023, sorry. It's still in good condition, but maybe a little bit deteriorating. So this is just another example of the how to easily use Roadroid to track change over time. Next. Okay, so I'm about to finish my presentation. We will have a Q&A if you have any questions. So my summary would just be to show you this picture again, to give you the basic one-pager understanding of everything that you would get in using Roadroid. And next slide, please. I come back once again with what I started with, which is what we see as the main benefits of Roadroid compared to other systems that are out there on the market. Low cost, easy to use, portable. More frequent service, you can use it on low volume roads. Image and video analyzing is, as said, the greatest potential, I think. And we have an API that allows you to integrate your Roadroid data, collected data, into your existing road asset management system. Next page. So that was my presentation. Sorry if it took a little bit longer, but we started a bit late as well. But if there are any questions out there, I'm willing to take them on now if there is any way to ask me questions so that I can hear them.
All right, we have some questions here. Just raise your hand. Okay.
My question is about the calibration issue. For example, now, if we have 2 engineers and they are using different vehicles, maybe someone is using an SUV and someone is using a regular Camry. The app, is it, in terms of calibration, is there consideration for the type of vehicle, suspension, and probably the pressure of the tire?
You're absolutely correct that you need to do a different calibration for every different type of car model that you use, at least that. Ideally for every, because it can differ a little bit between the same car model, of course, different. Even if they are the same model, they can still differ. But normally we recommend our customers to do one calibration for each different type of car, each car model.
Oh, thank you very much. We're talking about asset management, and based on my experience with rural roads, there was a time we had an app we were using for data collection, and I think one of the major reasons why you brought in your software, if I may say, because I've gone to your site and I've seen the app, is for us to be able to collect our data. My question now is the app free or is being paid for? That's question number one. Then question number two is, most of these apps that we have, they are mostly not for Africans based on experience, and there will be a need for us to be able to configure it to suit our situation, because our conditions are usually very different, and that's where most times we get it wrong in having to do. So to this regard, how can we get this thing localized for our African use?
Yeah, you're correct. Let me first start. No, the app is not for free. It costs from $425 per month if you decide to use only one unit for 3 months. If you sign a longer contract for 3 years and use more units, the price goes down substantially. It could be around $150, $200 per month. So I have a price list that I can share later on for anyone interested. Africa, we work in Uganda for the moment. They have purchased 32 licenses from us. So they cover their whole country with that, or the whole previous network that was under the UNRWA. So we have experiences in working on the African continent, even though there are, of course, differences in between countries as well on that continent. I had a couple of training sessions with Namibia a couple of years ago, and a couple of months ago, and we did a specific calibration procedure for Namibia. So we do actively help our customers to adjust to the road conditions that are specific for those countries. When it comes to image analyzing, we need to train the system for every different country. We start with the image analyzing. So in some ways you are correct that we need to do adjustments for the different road conditions of different countries, I would say.
All right, so
I hope that answers your question.
So thank you. So over here in Nigeria, most of us have Microsoft software. So your Roadroid, does it interface with these Microsoft softwares like Excel and all? That is one. Then the second question is, what is the maximum road width range when collecting data that your software, that your software can go, or data collection? Like our roads range between 7 meters to about 14 meters. So what is the maximum road width that you can collect data for? Thank you.
Yeah, sorry, the road was the first question. The second was road width. Yeah, the first was Microsoft. Yes, I mean, you can export the data and work with it in most Microsoft software. So Excel, for example, is the most common one, to export the data as an aggregate file into Excel. So that's no problem at all to work with Microsoft. And the second question was, sorry.
The road width.
Yeah, the width, the width, yeah. That's a little bit difficult to answer, but most of our, when we do our surveying, the most common way is to place our smartphone in the middle of the car, in the windshield, and then you would go and measure the road condition in one lane of the road. And if you want 2 lanes, you have to do the same procedure for the second lane. So you do right lane and left lane in the same direction. Some of our customers use 2 phones in the same lane. So then you would cover a larger width if you would have one smartphone based on the right side of the windshield of the car and another one on the left side of the windshield. So if you do that, you would also get a larger width of the road surveyed. So that's the best answer I can give you on that particular question.
Okay, good morning. I have 2 questions basically. The first one is, how protected is the data in the cloud? And can an institution have access to the raw data and now incorporate it in an existing application? That's one. The second one is with regards to the survey speed. For some of us who work in the rural area, you highlighted that the ideal speed is between 70 to 80 kilometers per hour, and it can go as low as 30 kilometers per hour. But even at that, you will find a situation where in some rural roads, you can't even achieve as high as 30 kilometers per hour because of the bad condition of the road. So how will it work in such environment? Thank you.
Okay, yeah, thanks for those questions. When it comes to, well, the cloud service is we used an Amazon-based cloud service where the data is stored. If there are specific concerns about data integrity, we can set it up locally with an additional cost on local servers. But in essence, the data is only available to the ones who have the login and the password to that specific account. So it's really up to the account owner, the customer, to decide on who he wants to share the data with. But once you are logged in, you can export all the data, and you can also use an API to integrate it with your road asset management system. About speed, I understand perfectly that problem. The app records IRI values down to 20 kilometers. If it's lower than that, it will stop recording because the value would either way not be accurate. And there's, if you can't drive more than 20, you really don't need an IRI value in most cases, because you know that the road is in a fairly poor condition in most cases. So 20 kilometers is the limit. However, it's still, the app still records photos or videos. So that data source you will have, not the IRI values under 20 kilometers, but you will still have the photos and the videos.
All right, I think, okay, we have, 2, 3 more questions.
Sir, the subscription, is it on multiple phones or per device? Is it for multiple devices or per? Yes.
What it means, single user or multiple users? For the subscription.
Yeah, for the subscription, we have different different prices for if you want to use multiple devices, you have to pay a subscription fee for every device that you use, meaning every smartphone. But if you are, let's say that you have a license for 10 phones, the monthly cost per license will be substantially lower than the $425 I mentioned for one unit only. So you would be down to maybe $200 per unit. So that's something that we we have a price list. I can share it, and we also do individual quotes depending on your specific needs. So everything is possible.
My question is, well, during your presentation, you talked about the app is sensitive to pothole. What I want to know is that sensitivity, is it in terms of identification, or can it tell us or show us the average size of the pothole? That's number one. Secondly, you said if you drive in a rural road, you could actually come to calibrate. That is, by watching the video, you enter that manually. That is to say, entering some conditions of the road. How is that done? And does that also culminate to like measurements? Then third, you say there's provision for API for integration with other apps, which I know we have some apps, which most of them are GPS related. I want to know, the API, do you provide for us? Do we have to like come back to the Roadroid to provide the API? Is the API automatically maybe somewhere that you can just do without necessarily coming back to you? And to what extent of softwares can the API be allowed to integrate with the Roadroid? Thank you.
When it comes to the identification of potholes, well, you could see for the IRI values, it will of course differ depending on how extensive, how large the pothole is. The AI system for automatic detection of potholes, it's right now only for the frequency of potholes within one photo. So it's not really looking at the severity of it. Then you will have to go in and look at the photo again. The IPA script, we have a script that works for most integrations. Sometimes it needs adjustments, but then we help with that from our tech team will support that. But on our web page, the API script that we have is available for download, and I don't think we have failed with any integration into a road asset management system, at least yet.
Well, my question is like this. We have other integrated software, most of us are in RAM. We have our NetTeams, which is incorporated with, what do you call it, our softwares, which we have the area, which we can also have our areas, our points, our pictures, and we can also track the routes, whether by what you said, using the vehicle or by trekking. But in the case of the rural area, which in some places here in Africa we have to trek to get even the points, just like any other GPS device. And for you telling us that the minimum distance is 20 kilometers per hour, so that means it's only applicable to existing routes. That's number one. Number two, now, just like all the points must be related to survey-related software, like the QGIS and the maybe Civil 3D and other softwares. What formats of the result are we expected to have? Then the third one, okay, which I've also mentioned, the areas. Even though we are more concerned about the points, which is related to the world coordinate system. So what about the areas? Can you get points and connect them together to get the area of anything you want to take? Thank you.
Yeah, sorry, there was some garbling that I'm not really sure I got the question. Maybe I have to repeat some of it, but For integration, again, we do have an API. We have the possibility, and you do need a GPS connection to be able to map, of course, the data that you have collected. Again, both the photos and the IRI values, if you want to map it. So that may have some limitations. And when it comes to speed, yes, it's no use really to record an IRI value if you go under 20 kilometers. It is possible to do by using a setting in the phone that is, we call it a bike setting, because we actually do have some customers who use our system for bike roads. So you can sort of override if you want to record IRI values under 20 kilometers. You can do an override for that. I'm not sure if that really answered all of your question. It was a little bit. I didn't catch all of it, sorry.
Thank you very much, Mr. Mikhail. You have done justice, and I believe by now we understand what Roadroid is and would all subscribe to it. Yes or yes? Thank you. May I now invite Engineer Isai Mwabinu to address us and say thank you to our presenter, and then we'll give you the announcement.
Thank you so very much for your cooperation, for allowing us to have him before the tea break. I want to thank you once again. And to Mikhail, I don't know if you can, if he's still on. Yes.
I'm still here.
We want to thank you so very much for the cooperation you have shown to us. This is the third time also you will be addressing us during our training program. We believe that we'll begin to modernize it. We want to get all our engineers to have access to the latest in the market, anywhere in the world, to be able to handle whatever project they have using the latest softwares and the latest technology available anywhere. The AI component of some of what we are doing will also be presented. I think that is for tomorrow. Exactly. So once again, Mikhail, thank you so very much. We appreciate. And the same my regards to Lars whenever you get in touch with him. Thank you very much.
Thank you. Yeah, I will send you regards to Lars, and thanks. It's always a pleasure to be part of your seminars, Isa. So let's keep in touch. And my contact info, I presume, will be available for everyone who wants to contact me directly and ask more questions or find out more about Roadroid. So again, I won't take up more of your time, but thank you very much for having me.
Can we please put our hands together for Mr. Mikhail? Thank you. And thank you for your patience. So we now go for our tea break for 15 minutes. So we are back by 12:05. Thank you. Okay, yes. 15 minutes will be 12:05. I give you a bonus of 1 minute.